Hello, everyone, and welcome to another round of data talks around Data Innovation Summit this year. And today I have the pleasure to talk with Fredrik Thuring, Head of Operational Analytics at Trygg-Hansa Försäkring. Fredrik, thank you for joining us. Can you please tell us more about yourself and your organization, your professional background, and current working focus?
Sure, Natasha. Thank you for having me. So yes, I'm heading the operational analytics department. It's one of the several analytics department at Trygg-Hansa and also at the larger company Trygg, which Trygg-Hansa is a part of. So what we do is we develop and maintain ML algorithms for kind of the inner workings of Trygg-Hansa. So basically, every manual process that can be either exchanged or just supporting an ML algorithm that is our job to develop and maintain.
Thank you for the introduction. And at the Data Innovation Summit, you will share more on very interesting topic about employing AI to detect insurance fraud. Can we know what the delegates at the event can expect from your presentation?
Well, a rather hands-on demo of how to kind of get from end-to-end process development-wise of a AI algorithm for fraud detection. So I'm going to talk about the data we've used, what kind of platform we have been using, and what software we have been using. And I should also mention that this is a totally in-house developed solution, which we have kind of connected to our claim system. So it's and also I'm going to tell you about how to employ it and develop it in kind of a step-by-step manner. So first deploy a rather simple version, make that better, make the scope wider, and then you start adding features to that AI algorithm to make it perform better.
Insightful. And at the beginning, you mentioned something about the company, but can we know more about it, and especially why this solution was needed for the business?
Yeah, sure. Well, being a large insurance company, we of course receive thousands of claims each day, and well, most of the claims are of course valid and should be handled swiftly and just help the customer in the best way possible. But there are a few claims where the claimant has, into various degrees, a fraudulent intent or seems sometimes just making up the claim as they go by. And we want to handle those both swiftly and kind of objectively. To do that, you need a lot of data and you need to process that data fast. And that is why we created this mathematical algorithm, this AI system that kind of works behind the scenes from the claims handler claim system, and in real time just screens the relevant data points that the claims handler enters in the system to assess, is there a degree of fraud in this data capture, and when it is, it kind of suggests to the claims handler that this claim, the AI found something that you should be aware of. Please review this one more time, or either continue just with the handling, or if you agree with the claim system or the fraud system, send that claim to a kind of our special investigation unit or kind of the back office to kind of handle it in a more rigorous way in terms of fraud.
Thank you for sharing your expertise on this. And what type of data and platform actually you needed to train the machine learning model to detect insurance fraud?
Yeah. So the kind of the core of the fraud system is trained on a rather, I shouldn't say standard, but I mean a supervised fashion. So we looked at the claims in the past, and we looked at the fraudulent claims which we could have found, and kind of match those together to see, or to have that as training data for our algorithm. And it's basically more different parts with different ML algorithms connected. So the fraud system is kind of a landscape of different connected algorithms, kind of looking into each part separately.
Interesting. And do you face any challenges while developing the model or even deploying it in production?
I mean, one of the greatest challenge with kind of fraud modeling in general is it's very unbalanced, the data set. So fraud is very seldom. We're talking about less than 0.5% or something like that we can find in the data. So that is the first challenge, to kind of do a supervised learning on that data and try some kind of techniques to make the data less unbalanced. So that's the technical issue. Rather than that, I couldn't say that we found that many technical issues. But I think the real key here was that we found some simple model to start with, which kind of just analyzed a part of the claims flow, and then we kind of built from that to a system which now screens every claim in real time with, I think, well, not hundreds of data points, but a lot of data points at least, to be able to assess this kind of vast claim volume now.
That was good to know. Thank you for sharing. And can you emphasize some of other benefits of this solution for the company today?
Sure. I mean, I can't really disclose any numbers in that case, but it is finding fraudulent cases for the claims for the counter fraud team, and it has been a significant savings in those claims, which also in the long run benefits our customers who are not fraudulent, which is of course the majority, because if we can find these kind of fraud cases, then that will affect claims cost, and in the long run affect premiums for the rest of the group. And I should also mention, which I forgot in the beginning, that it's actually a second benefit of finding these fraud cases, because some of the cases are actually connected with organized crime and other economic crimes. So finding those also has a benefit, not only for our portfolio of insurance customers, but also as kind of the society as a whole, if we do this in the correct way.
Another insightful answer. And looking at the solution, do you think it's something that can be applied in other companies and industries?
Yeah, for sure. I mean, the approach is very general. And the approach is, if you have some kind of either claim system or basically whatever business system which acts as a flow of as a process flow, you can, as we have done, connect a containerized algorithm outside that flow and have that communicating via just a request response of data. So doing that in that setup and not implementing something in the actual business system or the process flow actually makes us a bit more agile, or very much more agile in kind of further development or adjusting or improving the model, because we don't have to wait for sprints or go release dates for developing in the main system. We can actually have it just tagging along, and we can decide on which tests and how to deploy it in the system.
I hope that this will be useful for those listening to this interview. And do you have maybe any final recommendations for anyone interested in employing AI and ML models for fraud detection?
Yeah, again, this I mean, very general way of innovating in general. Start small, make something work in production. Just make this request response work. You can have a very like we had in our first version, very almost a rule-based model. If then, and just feed something back. And then when we got that working, you can start looking into what's going on in this box here. Can we approve it? Can we find some relevant historic data? Is there some external data to the company that could be added? So I think that's the very quick and kind of easy tip. Start small. And start small in production and develop from there.
Great advice. That was great advice. And to our final question of this talk, according to you, what AI trends can we expect in the upcoming 12 months, let's say?
Well, tough one. I'd say more use of kind of exotic data sources, or what could I say, more complex data sources. So going from kind of a tabular way, I mean, there's a lot of companies working with this and working with text, speech, video, pictures, those kind of things, and also in the fraud context, looking into these sources, because there might be some explanatory information there as well. So that's one thing, and maybe not solely work with those, but kind of combine those with your normal or standardized tabular data. So that would be one thing. And also, I mean, almost all of the ML algorithms we develop is kind of a recommendation algorithm. So it assesses some information and then makes a recommendation to a human to act in a certain way. I would reckon that the kind of development goes to kind of we trust the machine to a higher extent and make the recommendation in some cases to be more of a action instead of a recommendation. So if we trust it, we should be able to make it to make some actions. Of course, having in mind the kind of regulatory limits to those things, but I'd say that's kind of inevitable that we're going in that path.
Thank you for sharing your thoughts on this as well. And in general, thank you for your time dedicated to this talk. See you at the Data Innovation Summit.
Yeah, looking forward to it.